Here we're back with the Kelp4less podcast. We've got back from vacation, Harley Smith, the hydro weight champion of the world. He's refreshed, he's energized, and boy, is he ready to spit some knowledge out at us. So good to have you back. Hope you had a good vacation. I'm the organic mechanic with Kelp4less.com, and we're just going to have a nice little conversation again, like we always do. Thanks to everyone who watches. Thanks to everyone who gives us the thumbs up and asks the questions. We're so thankful. I do have a topic to bring up. We have had quite a few questions on late season nitrogen. What's what's appropriate for late season? Different forms, so on and so forth. So I know Hardy can talk a lot about nitrogen. So let's just throw it out there and let's do the old N talk. Let's start saying things that, come down to N.
Yeah. Well, first of all, it's good to be back. Good to see you again. I don't know if I did a reset. I don't know if I'm really energized. I think I need a vacation from my vacation. I got home last night, did laundry, and just kind of collapsed. But I do have a fresh mind, if I can just remember who I am and what I do. But yeah, nitrogen. That's a good topic. I remember nitrogen. Nitrogen.
Let's bring you back down to earth level here, Harley. Bring you back down.
Back down from the trees and the stars and the universe. Okay. Well, nitrogen, in agriculture, obviously, is one of those prime limiting factors. There's some statistics out there that said that without the production of synthetic nitrogen from the air, taking nitrogen out of the air and making it into fertilizer, we could only feed about half of the world's population.
Oh, I haven't heard that. Wow.
Yeah, I mean, because the population has increased exponentially in the last couple hundred years. And nitrogen is one of those limiting factors. So it's one of those things that's a blessing and a curse because it takes a lot of energy to produce the synthetic nitrogen.
Yeah.
To take nitrogen out of the air under high temperature and high pressure to make it into the ammonium form. And then from the ammonia form, they're able to make the other nitrogen fertilizers. So every time the price of fossil fuels goes up, the price of nitrate fertilizer goes up. But think about the other side, though. Every time the need for nitrate fertilizer goes up, we have more carbon emissions because we have to use fossil fuels to produce the energy to be able to pull that nitrogen out of the air, which is not biologically active form, and transform it into a biologically active form. So
okay, let's pause right there for just a minute. I want to explain the process that you're talking about as far as the fossil fuels and how we create the synthetic nitrogen. So they use natural gas the majority of the time to really get those really hot temperatures. And the emissions just from that are phenomenal. And basically, we're just, heating up air. We're heating up air, and the nitrogen falls from the sky, just like what you're talking about. It's a huge manufacturing process and huge consumption of natural resources. So a lot of people don't understand that. So thanks for pointing that out. The amount of fossil fuels and things like that being used just to keep our grass green. Turf is one of the overapplied nitrogen crops anywhere. It's phenomenal how that goes full circle if you're into environmental issues as well. So I just had to point that out. Thanks for bringing it up.
Yeah. And the other statistics are by the year 2050, that's right around the corner. We're not talking, our great-great-grandchildren, but we're going to have an increase there'll be 9 billion. Is it 9 billion people, I think? We're going to have to increase agricultural production by 50% and water consumption for agriculture by 15%. So the trend isn't like, okay, now we plateaued out. Okay, great. No, it's going up. So we need, it's a dilemma. We need the
Hmm.
nitrogen to feed the world, but we also need to manage the nitrogen to protect and save the planet. So
Hmm.
where's the balance there? So
Right.
yeah, and
Right.
we know
Another
that
another good
nitrogen.
reason, another good reason to grow our own as much as we can. Grow your own. That's another good reason to do that. So good points, Artie. Sorry to keep interrupting you.
No, that's okay. I'm just rambling here a little bit about nitrogen, but it takes a lot of energy from photosynthesis just to assimilate the nitrates that we do use. So a lot of the nitrate fertilizer we're putting down on the ground either goes back up into the air, it gets washed away from the root zone because it's very water soluble, ends up in the streams, ends up in the groundwater, creates some runoff with algae bloom,
Okay.
which can have a devastating effect. There's toxic effects from that algae, and so it multiplies the effect. We're not using it efficiently enough, which is why the kind of work that you're doing to me is so important. And literally, I might as well mention this at the moment. Biostimulants, the very first biostimulant formulas weren't to improve plant growth. It was to help protect the groundwater. In Germany, we probably said this before, but there's some areas in Germany where the runoff from agriculture, nitrate runoff, in has been so severe that it's created pollution in the groundwater. Instead of milligrams per liter, parts per million, we're talking grams per liter in
Oh,
some
wow.
areas from the runoff in the groundwater that we drink. It was causing blue baby syndrome and also,
Yeah.
cancers, all kinds of health issues. So the Dutch government said, we need to put the best minds in our country into solving this problem because they knew that it was unsustainable. The nitrogen. So the scientists did that they hired some of the best scientific minds. I got to meet some of them and interview them on camera like this, but they did some nutrient analysis of the soil. They found out the soil had plenty of nutrients, but it was locked up and unavailable. So their
Wow.
whole purpose to develop biostimulants was to be able to improve the efficiency of the uptake of nutrition so that they could reduce the nitrate fertilizer in half and help protect the
Hmm.
environment. So solving that environmental problem sparked the scientists to make new discoveries, finding ways to improve the efficiency of the plants, to improve bricks, and have a lot
Hmm.
of un, unintended positive side effects for quality and yield
Hmm.
and disease resistance.
Absolutely. Absolutely. On that same note, I got to tell you, I had an exciting week last night, or excuse me, last week. I had a really exciting week, a lot of good visitors, and I got invited to do a presentation at a regenerative farm. It's one of our living water customers. And so um, it was neat to see. It was neat to meet everybody that shows up. And the grower that we work with, this ties right back into what you're saying about nitrogen and the overuse of nitrogen. Okay, so let me just start off. I'm not a no-till guy. I'm more of a minimum till guy, a light till guy. Okay, and so here in our neck of the woods where we grow potatoes, you really have to work the soil to get them planted and get them harvested and so on and so forth. And this gentleman up here, one of our good friends and good customers, started doing regenerative practices, quite a few years ago. So he calls it kind of minimum till potatoes. And he's getting his organic certification. But this ties into historically, we put 150 pounds to 200 pounds of nitrogen per acre on a potato crop, okay, over the growing season, okay. And then this customer implementing um, some cultural practices, implementing some regenerative practices, and using some biostimulants and other things. he grew a very nice potato crop with only 7 units or 7 pounds of nitrogen, if you look at it total. Now, that's just applied nitrogen that we had to do, organic nitrogen. We supplemented with compost. He did cover crops. We put some, liquid fish on early in the spring. He did foliar applications of kelp. We implemented living water. And to grow a sustainable organic, minimum till potato crop with only 7 pounds of actually applied N per acre, unheard of. So it's proof that if we implement some of the things we know, the biostimulants, the other forms, of soil health and compost and cover crops, this can be done. And, it takes a little bit of extra farming, but I mean, look at 140 pounds of nitrogen less per acre to still grow a very nutrient dense potato crop, unheard of. I mean, he's trailblazing. He's really setting a trend, and we'll release some more data on this, but it's just proof it can be done. So I just had to throw that in there.
No, that's it. That's what we're talking about here. How do we balance this? The dilemma. How do we feed the world? Okay, we need to do that. And how do we save the planet protect the planet? Because if we can't just do one or the other, we have to find the way in between. Because otherwise, you don't have a planet to inhabit. And water is such a precious resource. And if we're polluting the water, then that has an effect on everything else downstream.
Oh,
so
absolutely.
Yeah. So it's I really believe in nitrogen efficiency, and we know about the microorganisms in the soil. There are certain blends of microbes that literally you can reduce the nitrogen input by 50% just with the microbes alone, and without sacrificing the quality and yield. So if you can do that, the farmers should be out there jumping for joy. But and some of them are the regenerative ones that you're talking about. But most of the farmers now, I think, just have been brainwashed. I'm not going to say brainwashed because it's wrong, but brainwashed into thinking that, oh, you got to have nitrogen or you won't have the yield. And then you have to have excess nitrogen so that you get the optimal yields. It's not true, because you can get with the excess nitrogen too, even if it gets into the plant and doesn't run off. Oh, wow, it all went into the plant. It's going to take so much of the energy away from the plant. It's going to reduce the bricks, the energy that the plant has to grow and reproduce, to take up the other nutrients, to protect itself against pest and disease. So too much nitrogen means lowering bricks. Adequate, deficient nitrogen, same thing. We have to have the nitrogen for photosynthesis. But that in between, if we can find that level, like you're saying, we're adding just enough nitrogen so there's no longer the limiting factor, but use the other parts of nature to make its use more efficient, then we win. The farmers win.
Yeah, absolutely.
They make money, and we, the public, win too.
Yeah, absolutely. And a lot of farmers have been hoodwinked too, because people show up, use this product, you can cut your nitrogen use in half. And they've played that game and it doesn't work, so they go back to their practices that they know that work. It's a series of things. It's a series, cultural practices and preparation. Again, we always talk about prep for your growing season. Got to have a plan and preparation. But you're absolutely right. You're absolutely right. And one thing we know that's a fact, and we've talked about this quite a bit, especially in field crop production and in your industry and greenhouse too. Excess nitrogen always leads to limited calcium uptake, and it happens all the time. We see it all the time in agriculture. And that's always the answer: put more nitrogen on. Oh, the plants don't look good. Put more nitrogen on. And what we're doing, we're limiting the uptake of calcium at the same time we do that, and which directly ties into the mineral content, the density, the bricks, all that stuff's related to excess nitrogen.
Yeah. And I like what you just said too, though. It isn't just one thing. Oh, here's a product. Use this product. You cut your nitrogen. No, it's really part of a system. There's
Yeah,
microorganisms that fix nitrogen on the surface of the roots in real time, 85% efficient in production of fertilizer for the plant. But those microbes need nitrogen too. They need nitrogen to survive, and they need carbon. So if we don't give the microbes everything that they need, they're not going to be able to work at their full metabolic capacity to be able to process
that's
that
right.
nitrogen. So it isn't just, well,
That's
let's
right.
give it this product. We need to balance the inputs. And I wanted to pick your brain a little bit on this. There's one nitrogen source that microbes use is the amino acids,
Hmm.
which are used to make the proteins. They contain the nitrogen. I worked with one grower who was one of these kind of guys like you were talking to me about earlier. Pretty smart guy. He's got a lot of experience, and he was doing aquaponics, and he did different trials with nitrogen in the system, and he found that amino acids were the most stable form of nitrogen that he could use in the in his aquaponic systems. And I think
Hmm.
part of the reason why was because it was feeding the microorganisms that are in the biofilter that are converting the ammonium into nitrates for the plants to use. So it has a stabilizing effect. So I just want your input on, the effects of amino acids, but amino acids as a nitrogen source. I
Oh
know that the
yeah,
amino acids
yeah.
they're large. Wait a minute, before I answer that, the proteins are a very large globular protein with 10,000 to over a million Daltons. They're very, very large, where sugar, glucose has, about 16 molecular weight compared to a million. Plants aren't
Hmm.
taking up amino acids to for their nitrogen needs, but it's
Hmm.
part of that chain with the microbes. So that being said, what is your take on amino acids as a nitrogen source?
Yeah, you bet, you bet. So, if you look at forms of nitrogen, we have nitrate, we have ammonia, we have urea, and then we have protein. Okay, plants can eat protein, but it is a nitrogen source. Okay, so when we use protein nitrogen forms of that, which there's many forms of protein nitrogen. Once it gets into the soil, it needs to be broken down. It needs to be broken down through biology, and it's broken down into smaller and smaller pieces, peptides and polypeptides and amino acids. And then through the biological conversion, it gets converted to forms that a plant can uptake. And that happens through biology. And this happens with exudates from the plant coming down to the ecosystem, to the microbes, saying, okay, I would like this. And it'll take those polypeptides or broken down amino acids and consume them and turn them into plant available nitrogen. So that's one way to do it. Now, if you have a very good, clean, pure amino acid source that it's broken down so much, the nitrogen can also be absorbed foliar with amino acids.
Hmm.
And we've seen that many, many times, but it needs to be a very good, pure source, like what we sell here at Kelp4less.com. I know you've used some human grade, internal grade or human grade amino acids in some of your studies, I think, or pharmaceutical grade, I think that's what you call it, and things like that. So that's kind of my interpretation.
Biotech grade. It was called
Yeah,
biotech grade back in the old days. But yeah.
biotech grade. Okay, so that's kind of my interpretation of the whole, nitrogen uses, amino acids, proteins, and that. And correct me if I'm wrong, but that's kind of how, we relate to our customers of what's going on with the proteins and the amino acids.
Yeah, that's good. The amino acids are the most broken down part before the microbes use that. Use the amino acids as for their nitrogen. They have to digest it too. I mean, that's what they're doing. They're
Mhm.
digesting it, the proteins, so that they can feed on the nitrogen, and then the leftovers go to the plant. Now there was years ago, I don't know how long ago, but there were people used to say that were selling the amino acids back in the old days that didn't have all the science yet, that it was a nitrogen source. The plant would take it up, the amino acids, and they can't. But they have to expend energy to be able to take it up. Now, if there was nitrogen limiting conditions where there wasn't enough of the ammonium, not enough of the nitrate, it's very limiting, then in those conditions, plants may take up as much as 15% of from the amino acids themselves.
Amino acid.
There's some areas like with very nitrogen limiting up in the Arctic area, not all the way up there, but
Oh,
in that zone.
right, right.
And those plants, those alpine plants, do use amino acids as a nitrogen source, but that is such a small portion. You really, it's hard to even say it's going to have that much of an effect on yield as a if you're using amino acids for directly for nitrogen,
Right,
but indirectly,
100% that's your source. Yeah, yeah. And
yeah.
so you're talking about if you just were using amino acids for 100% of your nitrogen source, that's what you're talking about, right?
Well, if the plants, well, it has to be like what you said. It has to be converted. Even the amino acids have to be converted into ammonium or nitrate. No, urea, they're not
Hmm.
going to do that. Or
Hmm.
some usable form. Usually it's ammonium or
Hmm.
nitrate
Hmm. Bless
before
you,
it's
bless you.
available to the
Yeah,
plant.
yeah. And it's a good practice. There's a lot of times in a plant's life where it prefers nitrate, and there's times in a
Mhm.
plant's life where it prefers ammonia. It prefers amino acid, and I think you've done a lot to figure that out in your industry, in the greenhouses and hydro and so on and so forth. And you've had the luxury to be able to time and do that correctly. Hard to do that in the soil, hard to do that, especially on a large scale. And so that's why, I love having these conversations with you because hydroponically we can do so much in a little area. And to kind of circle back to what we talked about, the environment and where our food is going to come from, and you know a lot of what we do indoors can be directly related to producing large amounts of food for ourselves, our family, our friends, our neighbors, and almost do it precise. And so this is all related. Growing plants is all related, whether it's outside in the field or in a greenhouse or in your basement, as a matter of fact.
Yeah.
It's all related. So, yeah, I love these conversations. We could just keep going and going and going.
Yeah. You were back, circle all the way around to the beginning. The initial question, late season nitrogen. One thing that because you mentioned hydroponics. In
Yeah.
hydroponics, late season, we cut back on the nitrate nitrogen. Why? Because we've been feeding them exactly what they need, maybe a little too much. I try not to, but most growers do. And then it builds up. The excess nitrogen that the plant doesn't convert into proteins and so forth is stored in the vacuoles for later. So there's an excess of nitrogen. So we can go ahead and cut it back at the end so the plant can start to use up what it's saved, or use up its savings account. Now in soil, and I mean, physiologically it's the same thing, but as you know, in soil, and once you're outdoors and you start getting some heavy rains, that washes away the nitrogen. So what I've seen in soil a lot of time, a very common deficiency is nitrogen deficiency. So So with that being said, maybe there is a need for nitrogen toward the end of the plant because you've used up the reserves. Now, I don't know that for sure. Because I'm not the outdoor guy. But what's your final take here on late season nitrogen and
Yeah,
feeding the
you
plant?
bet. So yeah, in soil, especially if you're having fruiting and flowering plants, I like to convert all my late season nitrogen in ammonia form, or back to the protein amino acid form. With and sometimes small amounts of nitrate are needed too. I'm not saying don't use nitrate. We have a very solid mix. It's a 41838 that we custom blend and make here, and it has a small amount of nitrate in it, and small excuse me, that's got about a third nitrate and two-thirds ammonia blended together in this formula. And for our soil guys, that's a really good way. That's a good finisher. It's a good way to make sure there's a little bit of nitrate and then the ammonia along with the extra potassium finishing late. So it's number one, know your plants. Again, have a plan moving forward. And for late season nitrogen, I prefer ammonia, but sometimes nitrate is needed.
Okay. Yeah, I think
Yeah,
that's a good place to end. We want a combination of ammonium and nitrate, but again, it's the stage of the plant's growth. And the ammonium is assimilated in the roots. It doesn't take energy. Where the nitrate nitrogen is assimilated in the chloroplast. So that could
good
take
point.
away some of the energy that could be used to make sugars to be transported into the flowers and stored in the fruit. So that's a good point. Which form of
Yeah,
nitrogen at which time.
yeah.
I think it's
Well,
good
we
to
got
have a
one
little
answer.
ammonia early on too, for the same reason. Once it get
Oh
established, then we want to find that balance. And
yeah,
never mind,
absolutely,
I think we got it.
absolutely. Well, that was the longest way to answer a question we've ever done, but we made it back to the original question. Good job, Artie. We made it. So keep the
Okay,
questions
well,
coming.
yeah, maybe we'll talk about something else next week. We could
Let's
talk
see what
about night.
happens.
I mean, literally, we could talk about nitrogen for weeks if we wanted to, because it's
Yeah,
so important. It's such a critical balancing act for the
it's
plant
yeah,
and for the
it's what
planet.
everybody knows too. It's what everybody knows too. Yeah, it's the
Yeah.
first thing on the list.
Yeah, I could tell you stories, not today, but I could tell you stories about how ignorance and a little knowledge can be bad. And because I knew like everybody else knew nitrogen. Plants need nitrogen. The very first time I grew tomatoes, high nitrogen, had and, I had the biggest tomato plants in the whole neighborhood, no fruit. Because
Yeah,
really overdo it like I did, it can delay or even prevent flowering. Okay, so you can
yeah.
think about that toward the end. Maybe it's the other way around at the end to promote the flowering. Anyway, I think it's a good place to leave it. Food for thought for later.
So you got it. Okay. Thanks for doing this again, and we'll see you next week.
Okay, bye bye.
All right.